We're now going to look at a simply supported beam. So we've got a beam here and it's got two supports at A and B. And what we're going to do is we're going to work out the reactions at A, so the reaction on this support here, and the reaction at B at this point. So RA and RB, we're going to work out them. And we've got 2 point loads on this beam. So we've got the 5 Newton and the 10 Newton. So they're actually acting at these points here. And we've also got a UDL, which stands for uniformly distributed load. And it says here that it's 2 newtons for every metre of length. So we need to work out the length of this and then multiply it by that 2, and that gives the total load that the UDL is supplying. So if we add up all these together, 3 plus 3 plus 6 plus 2 plus 5 should give us 19. So we've got 6, 12, 14, 19. So we've got 19 metres. We times that by 2 newtons per metre. And what that will give us is 38 newtons. So we can see that the total load supplied by the uniformly distributed load is 38 newtons, and it acts at the centre of the load. So the halfway point. So what we need to do is take the length, which is 19 metres, the full length of this beam, or full length of the UDL, and if we divide that by 2, 19 divided by 2 will give us 9.5. So what that's telling us is that the UDL can be considered to be a load up to single point of 38 newtons, which is acting at a distance of 9.5 from the end. So the next thing we're going to do is we're going to take moments about point A. So take moments at A. So we treat A as a pivot. As a pivot point. So a bit like a seesaw. And if we do that, then what happens is the turning moments at A, the clockwise moments, if it's in a state of equilibrium, i.e. if it's not turning, the clockwise moments should equal the anti-clockwise moments. So we need to look at our beam and look at everything that's going to turn it in a clockwise direction about this point. So we can see it's the 38 newtons and the 10 newtons. So a moment is given by force times distance from the pivot. So what I'm going to do then is, since RA is the pivot point, we've got to look at all the distances of these forces from A. So we need to work out this 38 newtons. We need to work out this distance that it's acting from A. So we know we've got 38 newtons, 38. We're going to times it by whatever this distance is. Well, if the 38 acts at 9.5 from the end, but then RA is actually 3 plus 3 is 6 from the end, and that means this distance must be 3.5. So we've got to times that by 3.5, and the other clockwise moment is supplied by this 10 Newton force, and we can see that's 6 meters away from the pivot. So that's 10 times 6. And then if we look at the anti-clockwise moment, so that's anything that's going to turn it in that direction, we can see we've got the 5 Newton force is going to turn it in an anti-clockwise direction, and that's acting at 3 meters from the pivot. That's 5 times 3, and I'm going to add to that the effect of the support at B, so the reaction at B. And since that's 8 meters away, so 6 plus 2 is 8 meters, we've got 8 times RB. So we've got an equation now which will allow us to work out what RB is. I'm just going to tidy up the left-hand side there, just work that out. So 38 times 3.5, and then add to that 10 times 6 is 60. So we've got 193, and that's going to be equal to 3 times 5, 15, plus 8 RB. And so we're going to take away the 15 from both sides. I'll just write the 8 RB over this side. So 193 take away 15 is going to be 178. And then we're going to divide through by the 8. So RB equals 178 divided by 8. And I'm going to use a calculator for that. So 178 divided by 8. And that gives me that represented as a fraction, and if I press the SD button, that's going to convert it into a decimal, 22.25. 25 newtons. So that's RB worked out, 22.25. But we just need to work out what RA is. And to work out what RA is, we could take moments about RB and just do the reverse process, and then that would give us what RA is. But there's an easier way. Once we've worked out one of the supports, we can just say that the downward forces, since it's in an equilibrium state, which means it's not moving, means everything's balanced, the downward forces must equal the upward forces. So we can see the downward forces we've got are the 5, the 38, and the 10. So the downward forces, 5 plus 38 plus 10, must be balanced by the upward forces, which is RA plus RB. So if we add these together, 5 plus 38 plus 10 is going to give me 53. And we also know what RB is, so we can say it's RA plus the 22.25, which we've already worked out. We can now work out what RA is, because we can take away 22.25 from both sides. So RA, the reaction at point A, is going to be 53 minus 22.25. I'll just get a calculator again. 53 minus 22.25. And we get 30.75. So 30.75 newtons. And that's it. We've done it.